Number 17, an airplane is traveling due east with a velocity of 520 miles per hour. The wind blows at 60 miles per hour from an angle of west 30 degrees south. Determine the velocity of the airplane's flight. So to help us out, I'm going to first do a little drawing here. And the plane's traveling due east. So I'm going to make sure I have a longer axis going that way. So it's traveling due east. And again, north would, on a two-dimensional, be up. East is to the right. This is south. Here is west. So the plane travels 520 miles going east. And there is a wind. The wind is blowing on an angle of west 30 south. So let me change color here. I'll do wind green. West 30 degrees to the south. So something like this. And I'm going to have to correct it in a second because this is not actually correct, but here we go. We have that. And so we think the wind looks like this, with this being 30 degrees from the west towards the south. Again, the north, south, east, and west is relative to where you are. So once I move to the right over here, south is now directly below that. And so it'd be 30 degrees south, and this is 60 miles per hour. Put 60 there. Now, the thing that's not accurate about this, the thing we need to fix, is that the wind's blowing from this angle. So it's not actually blowing to that angle, it's blowing from it. So this actually goes from here this way. Now, the way to check this in the calculator is when we switch this arrow, all I'm doing is changing the hypotenuse to negative 60. That in the calculator will make the arrow shift up this way, and so it'll solve it correctly because the plane is actually going to move along this path from the original location to up there. That's what we'll find out. So to put the vectors in the calculator, I first ask myself, am I given an x, a y, or am I given the h and theta? Now this first 520 going east, that's an x value. So I'm going to write that vector as 520, 0. It's positive x because it's going to the right. The next vector, it's a slanted piece. So I'm going to write it as an h and theta. Because I flipped it, I'm going to say this is negative 60. And the angle from the x-axis would be going down from here, which if it's 30 degrees over there and this makes a total of 180, this would be 150 on this side. And since it's going down, we'd say negative 150. I put that in. So if I add those two, convert them to polar, I should get the magnitude. So let's go over to our calculator. And so the first vector was 520, 0. And I add it to the vector negative 60, comma. Don't forget the angle symbol here. And negative 150 because the angle's going downward. And I'm going to put the degree symbol. I'll add that before I convert to polar. I need to switch out of radian mode to degree mode. So that's what I do here. Hit make default. So I just clicked on this little button right there. And I'll say menu 7C4. This means the plane's actually traveling at a magnitude, or the velocity. That's what I'm supposed to figure out here. The velocity is the same thing as magnitude. The velocity is 572. I'm going to just say 0.75 miles per hour. That's my answer here. If I needed to know the direction, since this is a positive number, that means it goes up from the x-axis. So the direction would be given as east, I'll just say 3 degrees north. So it's a positive number, so that's going from the x-axis up like this. So that would be 3 degrees there when you round.